The wait is over. The Samsung Galaxy XR is here. It is the first device powered by the Android XR platform, delivering the hardware that unlocks an entirely new dimension of opportunity for your Android apps, the third dimension. Although it may sound daunting to have to deal with this whole concept of depth, you'll find that building an app for Android XR is really similar to building for Android. You'll feel right at home with the familiar Android suite of tools and libraries on Android XR. Jetpack Compose for XR brings you the composables you know and love and will get you blasting off with a spatial UI. What's nice about Android XR is that you don't have to create a whole new app to have an experience that works on the new platform. Existing Android apps will look and work a lot like they would on a tablet, but in a multi-window environment called Homespace. No additional changes are usually required. But to unlock the full potential of Android XR, we'll have to enter full space. When your app is in full space, your app takes center stage. All other apps are hidden, and your app can make use of XR features like spatial UI and other spatial media features. How about I show you an app's leap into the third dimension through an example? Roll the footage.
Step to the beat, only time I get down is when I move with the feet. Let me show you what I mean, everybody up out of your seat. Let me see you move like that, like what? Like that. Let me see you move like that, just like that.
You just saw Androidify, which uses the Gemini Flash and Imagine models to transform your selfie or text prompt into an Android bot of your own. It captions the photo and generates the Android bot, all through the Firebase AI Logic SDK. And out comes your personalized bot. I've always wondered what I look like as an Android, so let me take a selfie real quick. How does it look? This app works great and looks good on all types of devices, like candy bar smartphones to tablets and foldables. Its adaptive layouts are designed to work with various screen sizes. You can check the Androidify app out on Google Play and see how it's built on GitHub. Okay, back to XR. I'll start by just running Androidify on the device. That's the introductory screen running in Homespace. If we resize the app, we can see it switch to the compact layout according to the window size. Great! But at this point, we might be asking ourselves if there's more we can do to take advantage of all the space we have. How can we spatialize the app to make it more engaging for XR users? The foundation of an XR experience is the way your app can extend into the user's real world or virtual space. Unlike traditional screens, there are no screen edges in Android XR. A great spatial UI makes use of its space by breaking out into different UI elements. Let's start easy and add spatial UI functionality to this introductory screen. First, we'll add the Jetpack XR SDK dependencies to our project. Visit the Android developers page to copy these dependencies. After including the libraries, we'll add a button that lets the user transition to full space, which lets the app create spatial layouts. Then, we'll check whether or not the device could request to enter full space under the current conditions. Then, we'll make a new composable. We'll check if full space could be requested, then obtain an XR session from local session. Otherwise, this device isn't capable of displaying spatial UIs, and we don't want to render the button. When the button is clicked, we request to enter full space via the scene. We use the idiomatic expand content icon from material icons to indicate the action of going to full space. And then we put it into the top bar. For now, clicking it just shows the same layout in full space. Just like how Androidify has a compact layout and a medium layout, we'll make a new spatial layout. Our wonderful designer Ivy created her take on what a spatial layout for Androidify could look like. I love how the design incorporates the green squiggle and escapes the traditional rectangular UI. We'll spatialize this layout by introducing spatial panels, which are bits of UI that can display 2D or 3D elements. I see two panels here. One that the video card is in on the right, and one containing the main UI. And I want to bring attention to the top right corner too. That's what we call an orbiter, which is a floating element that often contains controls. Here, it is a button to go back to home space. Your user might want to multitask, so it's important to give them that option. Back to the code. We'll add the capability to use the spatial layout when we detect that the current capabilities support it. Then, we can render a new spatial layout instead of the compact or medium versions. The simplest spatial UI contains a spatial panel and a subspace. A subspace is a composed element that represents a portion of 3D space that can only have spatial UI composables inside it, like spatial panels. These composables are called subspace composables and are modified by subspace modifiers. Then, we can just put the original flat video player component that was already present in Androidify into the panel. Just like with a normal composed layout, we'll use the subspace modifier to control things like size, position, and rotation. We can even give the panel resize handles that let the user make the panel larger or smaller using a resize policy. A move policy lets the user drag around the panel in space. Let's see what it looks like in full space. The panel can be dragged and resized. The main content follows the same pattern, a spatial panel with 2D content in it. We can reuse parts of the medium layout for this too. Now, by putting these two spatial panels in a subspace, you'll have something that starts to look like our design. But these panels are a little too independent. I think it would make more sense if the video player would move when we move the main content panel. To do this, we can add a subspace to the main panel's contents. This introduces a parent-child relationship. When the parent panel moves, the subspace will move along with it. Finally, we'll look at the button that we talked about earlier, the one that transitions the app to home space. We'll implement that with an orbiter. Orbiters can be attached to panels and other spatial elements. They can be placed at one of the four sides of the content at a certain offset, and they can also be aligned along the other axis. And that's the first spatial layout done. In short, we spatialize this layout by identifying opportunities to pull layout elements into spatial panels, arrange them into subspaces, and use an orbiter to add a button to go back to home space. Now, I won't go over every layout in detail, but here's a few pointers for opportunities to spatialize. This creation screen uses the spatial row and spatial column composables to arrange panels to fit in the comfortable viewing area, just like you would use row and column in 2D composed layouts. In this layout, we break out of the rectangular layout with our complementary quotes in the background, which fade in and out near the sides. Finally, they customize an export screen, which brings the spatial layouts and orbiters all together in one screen. And that's how we brought spatial layouts to Androidify. I hope that this run-through can help you spatialize your own apps too. Make sure to visit these links to learn more about the Android XR SDK. Also, there's a bunch of resources on developer.android.com that will teach you about Jetpack XR and more. Try our code labs that will guide you through other spatial concepts, like environments. Also, you can check out all the code I talked about today and more on the Androidify project on GitHub. Okay, that's it for me then. This XR Spotlight Week is full of interesting content, so be sure to check out our other XR Spotlight Week posts. Thanks!